Hello and good morning on this wonderful Monday morning, and happy Star Wars Day. So today we're going to be continuing with our Pythagorean theorem. So last week, the last lesson was about 30, 60, 90 triangles, where the angles of the right triangle were 30, 60, and 90. So today we're going to be transitioning to another common type of triangle. So as we see in this picture, we have an isosceles triangle that has lengths of its legs of 1 unit and 1 unit. So reminder that the hypotenuse is the diagonal and the two legs are the two that are touching the right angle. So we're going to figure out what the measure of the other two angles, because we know one of the angles is a right angle. And if it's a right angle, that means we know it's 90 degrees. So what we're going to use is we're going to use that isosceles part to help us. So base angles of an isosceles triangle are equal. So that means that these two angles are going to be equal because it's an isosceles triangle. So now what we're going to do is we're going to figure out how much those two add up to. So we find that by taking the total amount in a triangle minus the angle we know, which is 90. And we do 180 minus 90, we get 90. So that means this angle plus this angle add up to 90 degrees. And because they're equal, we can do 90 divided by 2 to find these two angles. And when we do 90 divided by 2, we get 45. So what are the measures of the other two angles? 45 degrees. Okay. So, and again, we got that by applying our knowledge of isosceles triangles and our knowledge about how many degrees are in a triangle. So now we're going to go to the next one. So it says to use the Pythagorean theorem to determine the length of the hypotenuse of the right triangle. So I'm going to write a helpful hint, which is A and B are the legs attached to the 90-degree angle. And C is the diagonal. Okay, so A and B are the legs and C is the diagonal. So we are going to start plugging in our numbers. So we have our first leg, which is 1, so we have 1 squared, plus our second leg, which is 1 squared. I'm going to go back and fix those squared so we don't think that they're equal to 12. So again, we're plugging the length that we know into the Pythagorean theorem. The length that we know plugged into the Pythagorean theorem. And then that equals c squared. C squared is easier to see, but okay. So now that we've plugged in our legs into the Pythagorean theorem, we're going to solve it. So we know that 1 squared means that we're doing 1 times 1, and 1 times 1 is 1, plus 1 again, because they're the same. And that equals c squared. In order to find the total amount of how much c squared is, 1 plus 1 is 2. So 2 equals c squared. So now, in order to find how much c is equal to, we need to take the square root of both. So, because the opposite of squaring a number is to take the square root of a number. So that means we need to take the square root of both sides. So what we're going to do, so let's see if I can find it. Insert special characters. So I found the square root button, and it's under Insert Special Characters, and then you can just type in root, and it should pop up, and then there's the square roots. And then there's the code for Google Docs as well, but I'll probably just keep using Insert Special Characters. So when you click it, it should insert, and there it is. So now I have a square root of 2 equals c. So if you wanted to type that in your calculator, you would get a decimal that's equal to 1.41. But if you can leave it in simplest terms of root, please do so. That way you can be the most exact as you possibly can. Okay, moving on to the next part. Is it necessary to write all 3 ratios of the shorter leg to hypotenuse, longer leg to hypotenuse, and shorter leg, longer leg? It's not necessary because the 2 legs are equal, right? So the 2 legs are equal. Whoops, I pushed tab instead of a Q. Okay, the 2 legs are equal. There is no shorter or longer leg because they're both 1, right? Because they're equal to each other in this word. Okay, that means that the only ratio that you need, both 1, means that the only ratio that you need is going to be leg to hypotenuse, because the legs are the same and the hypotenuse is the different side length. So moving on to part D, we're going to write the ratio. So what we're going to do is we're going to write it in terms of lengths. So what is the length of either one of the legs? So we look up here at a picture. It doesn't matter which leg we use because they're the same. So that means it's going to be 1, 2, the length of our hypotenuse. And the length of our hypotenuse is root 2. So I'm going to copy it from up there and paste it. So our ratio representing the leg to hypotenuse is going to be 1 root 2. That's the ratio comparing the length of all the legs and the length of the hypotenuse. So part E. By the angle criterion, any triangles with measures 45, 45, and 90 will be similar to this triangle. If a 45, 45, 90 triangle has hypotenuse of length 20, what are the lengths of the legs? Okay, so this is where our proportion knowledge comes into effect. So I am going to switch over to the dot cam so that it's easier to see. Okay, so what we're going to do is we know that C equals 20, right? The hypotenuse equals 20. Okay, so our job is to find what A and B equal. So what we're going to do is we're going to set up a proportion using the ratio we just figured out. So we just figured out our ratio of leg to hypotenuse. This is leg and hypotenuse. Okay, leg to hypotenuse. So now what we're going to do is we're going to set it equal to our known leg side or known side length, which is 20, and it's on the bottom because it's our hypotenuse. And we're going to just put an X so that we can keep our place and know what letter we're solving for. Okay? So now what we're going to do is we're going to cross multiply and divide. So we're going to cross multiply, right? We have X times root 2. Okay, we have X times root 2 equals 20. The crosses equal each other. So we have X root 2 equals 20. So now we need to get X completely by itself. So in order to do that, we need to divide by root 2. So then we get X equals 20 divided by root 2. So now we have to think back to Algebra 1 when we learned that radicals, or you can't divide by a radical. You can't divide by a root. So what that means is we need to multiply the top and the bottom by root 2 so that we can get rid of the root on the bottom. Okay, because when we multiply by root 2 on the top and bottom, it's the same thing as multiplying by 1, because anything divided by itself is equal to 1. So we're changing the appearance, we're not changing the value. And we're changing the appearance, not the value. So now we're going to when you multiply, you're going to multiply straight across. So that means on top, we're going to have 20 root 2. Outside numbers stay outside, inside numbers stay inside. So now on the bottom, when we multiply these two, we're going to get 4, the square root of 4, because we're multiplying the two inside numbers, because 2 times 2 is 4. And what is the square root of 4? The square root of 4 is 2. And that's how we got rid of the square root on the bottom, is we changed its appearance, not the value. And so now we can simplify this one step further, because we can do 20 divided by 2, and then we get 10 root 2. Okay, we get 10 root 2, which is our final answer. So now we're going to move on to the second problem. I'm staying on the dot cam because I want to draw a picture. So the next problem says, Claude sailed his boat due south for 38 miles and then due west for 25 miles. Approximately how far is Claude from where he began? Okay, so we're going to make an X to mark the spot where we begin. Okay. It's always helpful to draw a picture. It'll help you visualize what exactly it is that you're trying to find. So Claude sailed his boat due south for 38 miles. So we're going to draw a line down and mark it as 38. And then he went due west for 25 miles. So he went south and then due west. And this is his ending up point. He went 25. So when it says due, that means that we're going straight down and straight across, which forms a 90-degree angle. So now we have a triangle, or we have the beginnings of a triangle. And so what we're trying to do is we're trying to find the distance between where he ended and where he began. Okay, so what's the most helpful way to do that? We're going to find the length of the hypotenuse. So in this case, we're going to use the Pythagorean theorem, the a squared plus b squared equals c squared. So let's identify our a, b, and c first. So let's mark a as 38. Our b as our other leg, which is 25. And then we don't know what our c is, and that's what we're solving for. So now we're going to plug our a and b into the Pythagorean theorem. So we end up with 38 squared plus 25 squared, 25 squared equals c squared. So we're taking our two leg sides, plugging them into the Pythagorean theorem. Okay. So now we need to find out what 38 times 38 is to find out the squared. So 38 times 38 is 1,444. And then we're going to add that to 25 squared, which is 625. And those two numbers added equals c squared. So we're going to add these two numbers. It's 1,044. And we get 2,069 equals c squared. 2,069 equals c squared. And because since we're doing approximately, we can just push the square root button after we type that, after we find that in our calculator. Again, if you're using your phone, turn it sideways and push the square root x after you have this typed in your calculator, and it'll find the square root for you. And the answer is 44.4 0.49. And because we have a label this time, it's miles equals C. And we're going to round to 2 decimal places. The actual decimal is 45.48626, and it goes on for a while. Okay. So the 6 and the 3rd decimal place means that we round the 2nd decimal place up to 49 or to 9. So on your paper, I want you to have this part written for full credit. If you want to send me the picture of you doing it on a separate piece of paper, that's fine. If you have this written on a separate sheet of paper, that's fine. Just so that this is the part that I want you to make sure that you know. And actually, I don't even think I put this one on there. Did I? That was just another example. Oh, no, I did put it on there. Okay, sorry. Couldn't remember if I did or not. Okay, so now we're going to move on to part 3, or question 3. So it says, find the length of the legs in the triangle given the hypotenuse with length 100. Length 100. Okay, so now what we need to do is we need to figure out what information we've been given. So we've been given 2 of the angle measurements. So using our knowledge of the triangles that we used previous in this lesson, we know about 45, 45, 90 triangles. We know that this is a 45, 45, 90 triangle because this angle is a 45, this angle is a 90, and if we did 180 minus 90, we get 90, and 90 minus 45 gives us 45. So that means we can apply our knowledge of 45, 45, 90 triangles to this triangle. So I'm going to switch back over to the DocCam. Okay. So we're going to set up a proportion like we did on the last page. So we know that the leg to the hypotenuse is equal to root 2. And we're going to set that equal to our knowledge that our hypotenuse is 100. Right? Our hypotenuse is 100, so we know it's root 2. Okay, so now we're going to solve for our missing piece. So it's going to be very similar to the first example. So we're going to cross multiply. So we have 100 equals x root 2. Okay, 100 equals x root 2. We're going to get x by itself, so we're going to divide both sides by root 2. So we end up with 100 divided by root 2 equals x. So now in order to get rid of the root 2 on the bottom, we're going to multiply both the top and bottom by root 2. Again, we're changing the appearance. We're not changing the value. So now we end up with 100 root 2 divided by root 4 equals x. So we have 100 root 2 divided by 2 equals x, and 100 divided by 2 gives us 50 root 2 as our answer. So our legs equal 50 root 2. And that's our answer. Okay. So for this problem, I want you to have the proportions set up and our legs set up. Okay. So now we're going to move on to the last problem of this lesson. So the last problem, they gave us the legs and we need to find the hypotenuse. So they gave us our A and B, which are both 100. So we're actually going to solve this 2 different ways. Okay, we're going to solve it using our ratio, and then we're going to solve it using Pythagorean theorem. So we're going to start off by using Pythagorean theorem. Okay, so with Pythagorean theorem, we have 100 squared plus 100 squared equals c squared, right? Our leg 1 squared plus our leg 2 squared equals our hypotenuse squared. So 100 squared gives us 10,000. So we have 10,000 plus 10,000 equals c squared. We add those together. We get 20,000 equals c squared. So let's find the square root. So when we're finding the square root, we're going to factor so that it can be the most precise. So we have 20,000. So let's factor it. So we can go back to, we know that it divides by 2 and 10,000. And we know that 10,000 divides into 100 and 100. So we have a pair of numbers and a prime on the outside. So we can write the square root of 20,000 as 100, the pair on the outside, root 2 equals c. So that's solving it using Pythagorean theorem. So now we're going to use the ratio that we used the last round too, because if it has equal sides, then we know it's an isosceles triangle, and we know that the base angles are going to be the same. It's the same reasons that the example from the first part of the lesson have degrees of 45. Okay, so for the ratio method, we set up our leg over hypotenuse equals our leg over hypotenuse. So in this case, we know the leg, so we're putting it on the top. And so now we're going to solve for x. And in this case, we cross multiply and we get 100 root 2 equals x, or 1x. And since the x is positive and single, we have our answer. So our missing side length is 100 root 2. So the hypotenuse equals 100 root 2. Okay. So that is all for this lesson. If you have questions or you're just severely confused, reminder that my phone number is 414-367-7095. Okay, so that's a reminder. So text or call me if you have questions, and may the force be with you.